the inverse normal distribution. So we have a normal distribution, mean 50, variance 4, standard deviation 2. We want to work out the probability that a randomly chosen item that came from a population that's represented by this normal distribution has a value less than 47. Sketch, mean 50, we're shading to the left of 47, so we're looking for the probability of this region. So the lower limit, we need to use something outside of the values along this scale here, so let's say I'll stick with 0. Upper limit 47, standard deviation is 2, and the mean is 50. So this is our probability, 0.0668 to 3 significant figures. Now here is the exact same context, but this time we're given the probability, but the value of x here is unknown. So this time we have to use the inverse normal distribution. So from the calculator, menu, option 7, inverse normal, option 3. So we use option 3 when probability is given and we're trying to work out a value of our random variable. So the area is always cumulative. It's the area shaded to the left of some line that's drawn like this on your normal distribution. So in this case it's 0.0668. So don't put any percentages in here. It has to be a decimal value, 0 to 1. The standard deviation, the square root of our variance. I can put in 2, but just to demonstrate, you can put in the square root of a variance in here. And the calculator will work out your standard deviation for you. And the mean is 50. And we get 47.0 to 3 significant figures. So we've just worked out this value here. Example 1. So we're given a normal distribution, mean is 100, 3 squared, or 9 is the variance, so the standard deviation is 3. We're given a probability, we have to work out this value here. This is a specific value of our random variable x. So it says shade to the left 30% of the distribution. So we need something like this. And our unknown value k is here. So menu option 7, inverse normal. We have to check that the area that we're about to enter here is to the left of this line, the cumulative probability up to this point. So that's 0.3. The standard deviation is 3, the mean is 100, and the value that we're about to get will be k, so 98.4. Part B, so this time we're shading to the right about 30% of the distribution, but we know we're looking for cumulative probability. The cumulative probability to the left of this line is 0.7. We work with 0.7 and not with 0.3. So you'll see that I've put 0.7 into the calculator here. So 0.7, all the other values are the same. So this is the value of k. Part C, this time we're given the central 90% of the distribution is in between these two values. So on the sketch, the mean is in the center, and the sketch is symmetrical because the 90% is right in the center, so it's central. So these values are both 5% or 0.05, and we're looking for A and B. So the cumulative probability up to this line, so everything up to here, is 0.05. The cumulative probability up to this line is 0.95. It's not 0.9, it's cumulative probability we're looking for. Everything to the left of this line here. So the sum of these two, 0.95. So to work out A, we're going to use 0.05 here, and to work out B we're going to use 0.95 here. So we get these two values for A and B. Example 2. So our normal distribution has a mean 80, variance 8, and standard deviation root 8. We have to work out the values of A, B, and C. So to work out A, the cumulative probability to the left of A is 15%, so we use 0.15. To work out B, the cumulative probability to the left of B is 35%, so we're using 0.35. And to work out C, the cumulative probability to the left of C, and it's always to the left that we're looking for, will be the sum of the 15, 20 and 35%, so 70%, so the area this time will be 0.7. So we enter those values into the calculator and we work out A, B and C. Example 3. So this time we're given a probability between two values, one of which is unknown. So x greater than 16 or less than k, this region here, and the area here is, or probability 0.3. The probability x is less than k is this yellow shaded region. And the probability that x is less than 16 is this green shaded region. And if you subtract one from the other, so if we do the yellow region, which is less than k, minus the green region, which is less than 16, we'll get the region which is in between, which is what we're after, which represents a probability of 0.3. We can work out the probability that x is less than 16 because we know the mean, we know the standard deviation, we use the normal cumulative distribution function on the calculator, and it gives us a probability of 0.0912 for this. So this is a simple equation now. So if we just substitute that value into the equation here, the probability that x is less than k can be calculated next, which is this, just simple rearrangement there. And now we can use the inverse normal distribution because the probability is shaded to the left of this unknown value. The cumulative probability is here, inverse normal, and that value's there, and we work out the value of k. For practice, try these questions.